Hello everyone, today in this video I will talk about fundamental and derived units. What does it mean? So what are fundamental units? Fundamental units are in general those which can't be expressed in terms of others: mass, length, time, electric currents. This is defined in terms of force between wires but is fundamental in terms of electric circuits. The Newton is a derived unit because it is defined as the force required to accelerate 1 kg at 1 meter per second. Other derived units include power, work multiplied by time, pressure, force per unit area, density, mass per unit volume. Definition of some fundamental units: kilogram, a measure of mass; meter, unit of distance, defined as the distance travelled by light in 1 second, where c is the speed of c equals to the speed of light, about 3 into 10 raised to the power 8 meter per second. Second, unit of time, based on time taken, the number of vibrations or oscillation in cesium atom, 9.81 into 109. Dimensional analysis definition: the dimension is the qualitative nature of a physical quantity, length, mass, time. Square brackets denote the dimension of units of a physical quantity. Dimensional analysis can be used to derive or check formulas by treating dimensions on algebraic quantities. Quantities can be added or subtracted only if they have the same dimensions, and quantities on two sides of an equation must have the same dimensions. Now, vectors and scalars. What are vector and scalar quantities? Vector quantities have both a magnitude and a direction. Scalar quantities have only a magnitude. Vector quantities are those such as displacement, velocity, acceleration. Scalar quantities are distance, speed, work, and energy. Every scientific explanation can be explained with the help of a number of physical quantities. Each expresses a special meaning and significance. In that context, according to the definition, a physical quantity is the measurable and quantifiable physical property that carries unique information with it. Based on the dependency of direction, physical quantities can be classified into two categories called scalar and vector. Both of these quantities are in use to represent the motion of an object. Definition of scalar quantity and vector quantity: the quantity which has only magnitude and no direction is termed as scalar quantity. For example, length, mass, speed, etc. are some of the examples of scalar. Vector quantity: the physical quantity which comprises of both magnitude and direction is termed as vector quantity. For example, velocity, momentum, force, etc. are some of the examples of vectors. Thank you.